Hey everybody, Mike here from DIY Aqua Pros. Today we're talking about nitrogen-based compounds in the aquarium, specifically ammonia NH3 and ammonium NH4+. We're going to talk about where they come from, what the differences between the two forms are, and more importantly, how pH plays a role in ammonia toxicity. Let's start our discussion. In our aquarium, ammonia is generated primarily by fish waste and the decomposition of organic matter by heterotrophic bacteria. We want to limit the amount of this compound because it's extremely toxic to fish and most other organisms in our tank. Now, when this ammonia is released, the majority of it quickly picks up a proton, becoming the relatively non-toxic form ammonium. Thus, a ratio between the two is born. Now, this ratio is strictly controlled by the relative pH of our aquarium. Ammonium has an acid dissociation constant, or pKa, of 9.25, meaning that if a solution has a pH of 9.25, there will be a 1-to-1 or equal ratio of ammonia to ammonium. Now, as the pH in our aquarium changes, so does this ratio and thus the relative concentration of each form. As a matter of fact, each full unit of pH change will result in a 10-fold increase or decrease of this ratio, depending on which direction we move on the pH scale. For example, if our aquarium pH is 8.2, we will have 10 times more ammonium than ammonia. As the pH declines to 7.2, we'll have 100 times more ammonium than ammonia. From this depiction, we see that ammonia concentrations are reduced and ammonium concentrations are increased as the pH gets lower. To put this into perspective, we'll highlight another example. If we have a stable ammonia concentration of 2 milligrams per liter at pH 8.2, we will have a concentration of 10 times less, being 0.2 milligrams per liter at a pH of 7.2. If the pH continued to decline to 6.2, we would have 100 times less ammonia than we did initially at pH 8.2. Another key feature of these two forms of nitrogen is that they exist in a constant equilibrium with one another, meaning that if our pH remains stable, the ratio between them won't change even if one form is increased or decreased. This is called Le Chatelier's principle, or the equilibrium law. For example, say we have 3 molecules of ammonia and 300 molecules of ammonium, fulfilling our 1-to-100 ratio at a constant pH of 7.2. If our plants consume 101 molecules of this available ammonium, this will in turn force 1 molecule of ammonia to protonate, forming ammonium, thus restoring the ratio of 1-to-100. This is just one of the several biological processes which work in our favor to detoxify this compound. Now, when we look at the big picture, there are several different ways in which both forms of nitrogen may be removed. Biological filtration is the process of ammonia being oxidized to nitrate by nitrifying bacteria in our filter and throughout our aquarium. Plants, algae, and other microbes can incorporate free nitrogen into their biomass, and both forms can be removed by performing water changes. To review, as the pH of our aquarium decreases, so does the relative amount of ammonia. This in turn increases the amount in the ammonium form. As the pH of our aquarium increases, the opposite effect occurs. Ammonia increases and ammonium decreases. The ratio between these two forms of nitrogen exists in an equilibrium and is strictly controlled by the pH of our aquarium. Several methods exist to remove this nitrogen, including biological filtration, consumption by plants and algae, and from doing routine water changes. To learn more about nitrogen-based compounds in the aquarium, as well as the specific mechanisms which plants use to detoxify the environment, check out more of our aquarium science videos on our website.